All right, activity 8.2, using diagrams to show that expressions are equivalent. So this is just demonstrating how we could use diagrams to explore whether expressions are equivalent. So we've got some nice grids, and we're starting out with an example. Here's a diagram of x plus 2, so x and 2, and 3x, x, 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 when x is 4. So you'll notice that each of the segments labeled x are made up of 4 boxes. Notice that the two diagrams are lined up on their left side, so they're lined up on the left, but what we notice is they are not lined up on the right. So x plus 2 and 3x are not equal when x is equal to 4. Okay. So now we're going to do some. In each of your drawings below, line up the diagrams on one side. So we're going to line them up on the left side, just as in our example. Draw a diagram of x plus 2 and a separate diagram of 3x when x is 3. So we're going to be duplicating what was done up here, except instead of x equaling 4, it's going to equal 3. So first I'm going to make my x plus 2 when x equals 3. So there's my x when x is equal to 3. 1, 2, 3 boxes. And then 2 is 2 boxes. Okay, now I'm going to line these up on the left, and I want to make 3x. But again, this is 3x when x is equal to 3. So there's 1, 2, 3. There's another x, 1, 2, 3. And another x, 1, 2, 3. And again, they're lined up on the left, but not on the right. They are a different length. So x plus 2 is not equal to 3x when x equals 3. All right, now our next one. Draw a diagram of x plus 2 and a separate diagram of 3x when x is equal to 2. So we're going to continue in this fashion, but this time x is equal to 2. So first I'm going to make my x equals 2, and then that's plus 2. And then I want to start them on the same spot on the left, so I want them lined up on the left. And now I'm going to draw 3x. So there's 1x, 2x, 3x when x equals 2. So again, when they're lined up on the left, they don't line up on the right. So x plus 2 is not equal to 3x when x equals 2. If they were equal, they'd be lined up on the right side as well. Okay, let's go to the next page. And we're going to continue. Draw a diagram of x plus 2 and a separate diagram of 3x when x equals 1. So this time, x is just going to be one box. So there's x, and there's the plus 2. And now I need to draw 3x. So I want them lined up on the left. So there's 1x, 2x, 3x. And what do you know? They line up on both left and right side. So this tells me that x plus 2 is equal to 3x, but only if x equals 1. Lastly, draw a diagram of x plus 2 and a separate diagram of 3x when x equals 0. Well, if x equals 0, it doesn't even show up on our grid here. So I'm just going to draw the x plus 2. And then the 3x doesn't show up at all beneath it. So again, I can say x plus 2 is not equal to 3x when x equals 0. Okay. So when are x plus 2 and 3x equal? Well, we can see from our diagram that they are equal when x equals 1. So x plus 2 is equal to 3x when x equals 1, but not when x equals 4, 3, 2, or 0. Okay, use your diagram to explain the only time the left and right sides lined up was when x was equal to 1. So that's our explanation. Now, draw a diagram of x plus 3 and a separate diagram of 3 plus x. Now, they don't give us a value of x here. So I'm actually just going to start this over on the side here because I really don't have a value for x. So I'm just going to draw a box and say, okay, that's my x, and that's 3. So that's my x plus 3, and then my 3 plus x is going to look like that. And I can see the left side and the right side line up. And I don't have a value for x, but if I make x the same size in both diagrams, and 3 is going to be the same size, I can see they're going to line up. And this isn't a big surprise. I mean, this is really just the commutative property. When you're adding two numbers, it doesn't matter what order you're adding them in, or any string of numbers. It doesn't matter what order you add numbers in. If they're the same numbers, they're going to have the same value. So then if I wanted to just use some different values of different values for x, if x equaled 1, then x plus 3 is going to look like that, and 3 plus x is going to look like that. And I can see they're the same. If I let x equal 2, x plus 3 is going to look like that, and 3 plus x is going to look like that. And I can really see it really doesn't matter what x equals. X plus 3 is going to equal 3 plus x, which tells me that they are equivalent expressions regardless of what value I choose for x. 3 plus x and x plus 3 are going to be equal. So when are x plus 3 and 3 plus x equal? X plus 3 is equal to 3 plus x, 3 plus x for all values of x. And when are they not equal? Never. Use your diagram to explain. And we kind of did that. Oops, sorry you couldn't see that. So x plus 3 is equal to 3 plus x for all values of x. When are they not equal? Never. And there are our diagrams up there for explanation. Okay.